Hello, grade 10, Mr. G here, and we're going to be making a video regarding transverse wave. The exams are coming, and it will help you to answer certain questions. Okay, so this question it's taken from November 2013 in the Northern Cape. Okay, now the question says as the diagram below is an illustration of a transverse wave. Define a transverse wave, and then you see the diagram. Okay, use the above diagram to answer the following questions. Write down two consecutive points that are in phase. So we are going to be looking at points that are in phase. We're going to be looking at that. 1.3, write down the magnitude of the amplitude. We're going to record what an amplitude is. 1.4, how many waves are illustrated above. 1.5, if the wave takes 3 seconds to make the wave pattern A to E above, calculate the period of the wave. We're going to be looking at the period, and we go into the illustration quickly. We can see they are giving us the distance from A to E, as well as from B top to C bottom here on this straight line distance, this one here. Okay, so if we move there, they say calculate the frequency of the wave. We are going to be briefly looking at the definition of frequency, and 1.7, calculate the wavelength. We're going to be looking at wavelength also of the wave and calculate the speed at which the wave is moving. We're going to be using table 4, which is going to be given in the exams. There is the formulas they are going to give you in the exam. They're not going to give you more. In this topic, the relevant formulas are only this one and this one here. The other tools at the bottom here are not going to be used for this specific question, but later when you do electromagnetic radiations. Okay, so we're going to look at these questions, and we're going to start answering the question. All right, so now question 1.1 asks about the definition of transverse wave as done in the class. Now, what is a transverse wave? A transverse wave is the one where the particles of the medium move perpendicular to the direction of propagation of the wave. Particles of the medium move perpendicular to the direction of propagation of the wave. So that is what we call a transverse wave. Transverse wave is the one where the particles move perpendicular to the propagation of the wave. For instance, let's imagine this here is a wave. It could be a wave on a rope, it could be a wave, a water wave, or any medium. Okay, now this is made up of particles, and obvious I cannot represent all the particles. Now these particles are going to move either up. In this side, for instance, the particles are going to move up, and on this side is going to move down. This side is going to move up, particles, and this side is going to move down. It's like if you have a floating piece of wood on the water, you see it's moving up and down. These are the particles of the medium, the particle of the water, the particle of the rope, the particle of the air, whatever medium it is. However, the wave is going to move in one specific direction. This is the motion of the wave. So you can see that the motion of the wave is at the right angle or is perpendicular to the motion of the particle. Motion of wave, this here is motion of particles. Motion of particles. You can see that they are at right angle to each other. Okay, this is question 1.1. Let's look at question 1.2. Now, question 1.2 said write down two consecutive points that are in phase. Now, points in phase are points that have the same motion at the same time. Those are what we call points in phase. So points in phase are points that have the same motion at the same time. Same motion at the same time. For instance, if we look back at the drawing top here, this point here does not have the same motion as this point here, as one is moving up and one is moving down. But instead, this point will have the same motion at the same time with this other one. And this would be, for instance, 2 points that are in phase. Both of them at the same time are moving up. Alright, now here you can see another 2 points that are in phase. This one here is in phase with this one here. Those 2 points are moving down at the same time in the same way. So those are 2 points in phase. So saying that, if we go back to the actual graph or diagram they gave us here, which ones are the 2 points that are moving in phase? And those are point B and point D. They have the same motion at the same time. So the answer then is B, D. Points B, D. I'm going to write just B and D. Those are 2 points that are in phase, and are the only 2 points in phase in this diagram. A and E could be in phase, but this is also called rest position. So I prefer to say B and D. So let's go to question 1.3. Write down the magnitude of the amplitude. Now, what is amplitude? Amplitude is the maximum displacement from rest position to either the peak or the trough. Okay? So amplitude is the maximum displacement of a particle from its rest position, or could be also said equilibrium position. So in other words, it's how far from rest that particle goes either up or down as it moving in the wave, as the wave propagate. Okay, so let's look at the following sketch quickly. This point here is what we call rest position. This point is the point where the particles would be if they were not disturbed. Okay, if the particles were not disturbed, they will be there. Now, how far up this distance here, the maximum displacement from rest position, is what we call amplitude, or how far down the particle get disturbed. That is what we call amplitude. And those maximum point top is called crest, and the one at the bottoms are called trough. So this is a trough, this is a crest, and this is another crest. So the distance from rest position to a crest, or the distance from rest position to a trough, is what we call amplitude. So if we go to the question, they are giving the distance between B and C. So they're giving us the distance from a crest to a trough. The amplitude will be half that distance. Remember, the rest position could be here, which is cutting that distance half. And we have the distance from a crest to a trough. That means that the amplitude will be half that number, and therefore it would be 20 centimeters. So the answer here is amplitude is equal to 20 centimeters. They are not asking to give the amplitude in meters, so we can write it in centimeters. All right, so let's go to 1.4. Now, question 1.4 asks how many waves are illustrated above. So let's go back here and see how many waves are illustrated. So from starting point, which is here, we have one wave which is all this way up until there. That is one wave. Okay, and then from here we have the second wave, but it's not complete. If that wave was complete, we'll have to go all the way down and up again up until there. So the wave is not complete, and therefore how many waves are illustrated there is only 1.5. So it's 1.5 wave. So the answer of 1.4 will be 1.5 waves. That is the answer for question 1.4. Now, question 1.5. The question said if the wave takes 2 seconds to make the wave pattern A2E above, calculate the period of the wave. Now, by definition, period is the time taken for one complete wave. Now, the question is telling you that it takes 3 seconds from A, which is here, to E, which is there. So it takes 3 seconds for 1,5 wave. Remember, we identified the number of wave before. Okay, so now how are we going to approach this question? And then in this case, I would like to use simple maths. Okay, and these maths will be the following. We say 1,5 wave took 3 seconds. One wave, how much will take? And then I do cross product. So I do cross product and I do this. Then from here I have that 1,5 x is the time for one wave, which is the period, is equal to 3 times 1. When you calculate this simple calculation, it gives you x is equal, remember x is the period, and it's going to be equal to 3 divided by 1,5, which the answer is 2 seconds. So this is the way I used to do this specific question of the period. Very simple. Okay, so let's do 1.6, and we are almost done with this question. 1.6 say calculate the frequency of the wave. And if you come here, this formula relates period and frequency. So we are going to just first, as we did with all the other questions, look at the definition of frequency, and then we are going to use that formula to calculate the frequency of the wave. Okay, so let's go to the definition of frequency. Alright, so frequency is the number of waves passing a given point in 1 second. How many waves pass in 1 second? Alright, so with the formulas that we saw on top, we know that period is equal to 1 over frequency, or we can write that frequency is equal to 1 over period. And this is the one we are going to use. We have the period, which we did just calculate in question 1.5, 1 over period, and the period was 2 seconds, so it's 1 divided by 2, which is equal to 0.5 hertz. That is the answer for frequency. Very simple, but it depends on the period that was calculated in the previous question. Okay, so now we can go to question 1.7 that said calculate the wavelength of the wave. And here in the formulas you have the one formula that can help you to calculate the wavelength of the wave, but it's not the only one. Now we may not even use this formula here because we have another data. Let's go first, as we did all the time, find out the definition of wavelength. Okay, so let's go to the definition of wavelength. Okay, wavelength is the distance between any two adjacent points that are in phase. But in other words, wavelength is the length of one wave. If we go here, as well as we did with the period, we know according to the diagram that we have represented 1,5 waves. And the distance for 1,5 wave is 6 meters. So what the distance would be for one wave? So let's use the same approach as we did with the period, using mathematics and the cross product. Alright, so let's go here and do it in that way. We said that 1,5 wave is going to be 6 meters. So I want to know one wave, how much is it going to be. That will be the wavelength. And I'll do again cross product. So here I will have that 1,5 x will be equal to 1 multiplied by 6. When you do this, x, which is equal to wavelength, will be equal to 6 divided by 1,5. And the answer would be 4 meters. So that is the wavelength of this wave. And then the final question, they're asking us to calculate the speed, and then we're going to use this formula. We could not use the formula before because we didn't have the speed. Now is when we can use this formula to calculate the speed of the wave. There are many ways to calculate it. We are going to do only one. There's not the need of doing all of them. Right? So speed is equal to the product of frequency and wavelength of the wave. We have the frequency. It was calculated in the previous question, is 0,5 hertz. So this is 0,5 hertz. The wavelength is 4 meters. And then the answer is going to be 2 meters per second. That is the speed of the wave. Alright, this is the end of this question. I hope it helped. Please practice this work. It would be asked in the exam, and as you see here is 19 mark. It could be plus minus there. It will be a lot of mark. Thank you for watching. If you think it helped, please a thumb up. You can ask questions, you can suggest, and then I'll see you next video. Next video may be on another topic that is going to be in the exam. Thanks a lot. I'll see you next time.